Today, we're going to learn about the cooling system of the thermodynamics ultracut plasmas. Here you can see the cooling circuit of the plasma. Let's go through it step by step. First, the coolant is sucked out from the tank and through the pump. Next, we have the pressure relief valve. If the pressure is too high, the coolant will be pushed back to the tank through the relief valve. In the relief valve body, there is also a check valve. This prevents the coolant to flow back from the torch through the supply line. After the check valve, the coolant flows to the back wall hose connector, labeled coolant supply. From there, it travels through the hose to the external cooler, if the plasma is 400 amps or more, or directly to the remote arc starter if the plasma is rated below 400 amps. Inside the remote arc starter, the coolant hose gets connected to the torch leads. From the remote arc starter, the coolant travels to the torch, where you have the coolant tube. The coolant tube is a spring-loaded check valve that prevents the coolant from flowing out when the consumables are not installed to the torch body. After the coolant exits the coolant tube, the coolant cools the consumables and exits the torch. Inside the positioning tube, you have a check valve in the return line. This check valve prevents the coolant from flowing out through the return line. We then again come to the remote arc starter where the torch leads get connected to the coolant return hose. From the remote arc starter, the coolant flows through the external cooler if the plasma is above 400 amps, or directly to the plasma if it's rated below 400 amps. From the back wall hose connection, the coolant flows first through the filter and then to the flow switch. The flow switch measures the flow rate of the coolant. The flow switch requires a flow rate of 2.65 liters per minute to open. Flow less than that will result in a coolant flow error. The flow switch can only measure the flow of liquid. Any bubbles created inside the coolant hoses will result in a wrong reading of flow. From the flow switch, the coolant travels through the inverters to the radiator. The radiator cools down the liquid and it then travels back to the coolant tank. If for some reason there is too much coolant in the system, it will go through the overflow hose and drain outside the plasma. Most typical errors are 401, 402, and 404. 401 means that there is too little coolant in the tank. Please fill the coolant tank above the indicated minimum level. If the coolant level is correct, you can check if the switch is working properly. The level switch LS1, normally open, is located behind the coolant tank. It is wired to the relay PCB J7. Remove the J7 in the relay PCB and measure continuity between pins 2 and 4. The switch should be closed when there is enough coolant in the tank. If the switch measures open, replace the switch. Most common issue is gas getting mixed up with coolant. This creates bubbles inside the hoses and makes the flow switch not to function properly. Please inspect the clear tubing inside the plasma to see if there are any bubbles. Typically, the gas gets mixed into the coolant by wrong assembly of consumables or broken O-rings in the cartridge or torch body. Please see a separate video about assembling consumables and replacing O-rings. To measure the actual flow rate of coolant, you can turn off the system and remove the coolant return hose from the back of the plasma. Then place the return hose to a clean bucket. Power on the plasma and let the pump run and fill your bucket for 30 seconds. After the time has passed, turn off the plasma and measure the amount of coolant in the bucket. You should have a minimum of about 1.4 liters of coolant in the bucket. Anything less than that, and you know you have a restriction somewhere between the pump and the return hose. Check for pinched hoses and inspect for any leaks. Check for wear on the coolant tube. If there is any wear seen on the brass fingers of the coolant tube, replace it. If the flow rate is above minimum, the most likely issue is the coolant filter. Replace the filter and see if the issue clears. If all checks out fine, turn off the plasma and then remove the supply hose, example from the remote arc starter or from the external cooler. Then put the supply hose into a clean bucket. Turn on the plasma and run the pump for 30 seconds. After the time has passed, turn off the plasma and measure the amount of coolant in the bucket. You should have a minimum of about 1.4 liters of coolant in the bucket. If you have less than that, and the supply hose is not pinched, most likely the pump is broken. 404 comes if the coolant flow rate is below the required after the plasma is powered on. The plasma will try to achieve the correct coolant flow for 4 minutes. If there is not enough flow during that time, the pump will turn off and the plasma will give the error message 404. Troubleshooting steps for 404 are the same as 402. Thank you for watching and I hope to see you in the next video.